So, hello and welcome to Stonks, the real-time trading game. In today's episode we will talk about error handling in Python and software complexity, how to make less complex software and how to make your life easier. So first of all we talk about error handling. So in last episode we already did some error handling by checking the conditions if they are set. So if we check with a simple condition, if something is set like our coin ID, what we had is in the supported coins, then we calculate the stuff that was from, because we can have unsupported coins in our wallet, and we can do whatever we want. We can do a lot of checks, but in the end we can prevent errors. There's a system called exceptions, and C++ and others can other languages also have this kind of error handling. So the thing is that we can prevent those errors, or with exceptions we can prepare for these errors. So exception handling is what makes our life easier. It's called errors in Python. We can do whatever we want, but we can have problematic parts of our code base that can cause problems. They can, for example, if we want to open a file, and what if the file is not there? We can check, or we just go in blindly and we try our best and prepare when the file is not there. So, about Python exceptions. We have three main blocks if we try to do this with exceptions. First, we have the try block. Everything's in this try block, just like in an if we indent in one tab or 4 spaces. We put our problematic code here. This means that if this fails, we can handle the errors thrown or raised here. We prepare, we know that, for example, opening a file can fail. So we try to do this here, as the name try says, and we accept some problems later. We have the except block, and the except block is where we can try to handle the raised errors. Okay, this except block, if this happens, this type of error or any type of error happens, we do the error handling here. But since different types of problems need different solutions, we can have different error handler excepts, so we can have multiple excepts with different filters for different errors, but we will talk about this later. And last but not least, we can have an else block. The naming is a bit problematic because it's not so intuitive, at least for me. But when the try block is successfully done, we continue with the else block. If the try block fails, we stop executing the try block and we jump to the appropriate except block to handle the appropriate exception. And the fun thing is that it's not system stuff that's only done by the Python framework. We can raise our custom errors. We can raise normal errors, and even we could later create our very custom errors, error types too, not just adding a string to a already existing error, but that's will be a topic of later. Okay, in our case we are opening, or we are trying to handle files, and we try to check a web API. So what kind of errors can we accept? In this case we can have a file not found error, for example. That's very specific error. We can have very general errors like the exception that handles all the exceptions, as that's the base class for all exceptions in Python. But file not found error is a type of IO error, so we could filter for broader IO errors, or just if we can't find this file, then do whatever we want. Of course, since we are connecting to the internet, we can have network problems by at our side, or the server can be down, so we can expect the so-called connection error that's from the requests package, but I don't want to simulate it here because then the connection to the stream servers would be cut and the show would end, so we won't test that here. But these are the two basic types that we will try to handle today. And after handling the errors, we can talk about software complexity, because we have multiple points of failure in our code. Open the file, that's not there, the content is wrong, the API is down, so it's a bit complex part of code. So if we talk about complexity, one type of complexity is when we have multiple decisions what we can make. So for example, if we have two variables a and b, and we try to make a decision based on this, if you have only two variables, and even if they are correlated or not, or if they are connected or not, we have at the end four if, else, elif cases. But if we have three variables that we can choose, or we have to decide based on these three variables, if these three are really depending on each other, they are talking about some part of the system, that would result in 8 different cases. It's to power the number of cases. But if we have independent checks, independent stuff to decide on, that's only 2 times the number of this stuff. And with 2 or 3, it's not a big deal, but if we go up to 8, for example, 8 different variables, the number of cases that we should handle in the dependent case is just skyrocketing. It will be much more complex, and we won't be able to handle it normally. So this must be prevented. If we can, we can try to block or try to break down big block pieces of code to smaller functions. By that, if we have smaller functions, we have a smaller scope. It's easier to make that code work correctly. It's easier to maintain or edit later on, and easier to debug, easier to correct bugs if we find them later on. And we didn't talk about unit testing yet and testing, but if we have smaller functions, smaller functionalities that should be tested, it's easier to test them. So it's really beneficial to have smaller functions, smaller blocks. Also, if we have functions, we can reuse these functions later, meaning that if we write once and use it many times, we've already decreased code complexity. Also, we improved the readability, because the functions, the names tell us what it's doing. So it's better to make smaller functions that it will describe what the code is doing, and it will be easier to write. What will we do today? We will add some basic error handling to our code base. We will store the list of coins, that's the supported coin list. We will store our wallet's content, what kind of coins we have and how many, and of course how much USD we have left. And we store the latest exchange rate, so we can instantly show that last time your wallet was at that much value, and later on you can check on, even when the internet is broken or the server is broken. It's a fallback mechanism, so even if we can't update, we have something to depend on, even if it's outdated anytime. And yes, we will need periodic checks later, we just don't do it yet. But before that, let's start coding. We have our basic coin class as last time, and we have our wallet. We already did some functions. With many years of experience, it will be like taking breaths and stuff, that you try to break down stuff into functions. We already have our method list of coins. We will have to rename it because it's not just list of coins. Update the supported coins list or something like that. That name would be better. So after we updated the list of the supported coins, we load our wallet and we will update the exchange rate. We can fail at all three cases, but the supported coins list is the biggest problem. That's where the first check comes in. Then we have to load our wallet, and after that we will try to update our code. That also depends on the internet connection or the API, so all of these three can fail somehow. We have to handle this correctly. So, where should we start? We should start with the simple file loading stuff. We have a cute little wallet here. That was our mock. We faked one wallet, and every start we have this many coins. And of course, we have to add initially a 0 USD fiat amount what we have, because of course an empty wallet has no coins, no dollars, that's empty by default. And after loading we can have, of course, self dot fiat should be about, yeah, make 10k, 10,000 USD as the game starts. But that's still mocked. We have to load from a file. It will be hard-coded, it's not the best still, but open, and we will make a wallet.json. Later on we can replace this hard-coded JSON file with a custom save file, for example, but currently let's hard-code this. It will be a text file and we want to open it to read, to load, so it will be a read text, encoding the usual UTF-8, and open it as a file. Okay, this will be a JSON file, so we will have to load, yeah, it may be the coins, but let's just store it in a variable, self.loaded wallet, because we don't want to override the coins list or whatever, because we have to do some checks here too. So we load with the JSON.load, and load from this file what we opened here. If it succeeded, then we are in the green, and this should be fine. Go through each coin, what we have in the JSON, what we describe, but we have a big problem here. Let's test the exceptions in live. We don't have a valid.json here, so opening this will fail miserably. So let's start with, let's launch it normally as we would. And we will have a file not found error. No valid JSON was found. Okay, now we can go back here and do with debugging. Okay, exception has occurred. File was not found here. This is a problematic part. We can fail opening this file, so we try to open our file and try to load the JSON. Accept everything. If something goes wrong, anything, really anything can go wrong. We failed to load our save file, our save game, so we will reset our coins list to an empty coin list, and our amount of USD to 10k. So if something fails, the user gave a wrong wallet JSON or whatever happened, then we will automatically create a new wallet, because that's a fallback mechanism. It will work correctly. We start our game first, we don't have any wallet JSON from before, we want to start from somewhere. Self.fiat is 10,000. Of course we could have tabbed here, but whatever, that the lower layers are, or lower lines of code, what we want to remove, and we want to load these correctly. So if something went wrong, we have 10k USD, and the coins list will be an empty list of coins, and we can go on. We put our mocked data here. But as we saw, let's try to open the file, and if the file opened correctly, let's try to load our wallet. And even when the JSON fails or whatever happens, we can do whatever we want. So with the loaded wallet, if our wallet is correct, we can have some fun here, but yeah, currently we don't have any normal coin in the JSON, so we add, it wasn't in the task list, we add a save wallet function or method. But since we are in a wallet, we can just change it to load and save. Of course, correct where it should be corrected. So for each load, we have to save our little wallet. We open this wallet with write text mode. We want to overwrite the file if it's found, and we don't load this data structure, just we don't load from JSON, we dump something. We would like to dump, yeah, what would we need? We would need the coins and the fiat. So we make wallet to save. Let's make a dictionary. USD would be self.fiat, and of course coins would be self.coins, the list of coins. If you are familiar with JSON, it will start look familiar. We will have USD with a single integer value, and we will have the coins, which will be a list. How will we serialize this? It will be a fun ride, but let's try this. So dump this wallet to save, and the dump will need a file pointer, so we will add file here and hope for the best. So we normally don't have any coins. We have 0 coins, no wallet.json what we want. Normally, if we want to load our wallet, we will try to load this, but if we don't have a file, we will start with 10k coins, 10k USD and 0 coins. But if we will have our wallet, we will load our wallet first. And of course we have to print this too. We have to print out the sum USD too. No, we don't update here. The account's value is USD with wallet dot this much USD fiat. So at first run we won't have anything. It will say that we have 0 amount of coins and 10k USD in fiat. Okay, but after we did everything, while exiting our application, we have to save the wallet's status. Of course, we have to save after every transaction, but we don't have any buy or sell function yet. But let's try first with this. We have our new wallet JSON, we have 10k USDs and not a coin at all. And if I run it again, we will have the 10k USD because we saved our wallet. We will add this much coin to it, and of course then we will try to save it, and this may fail. Let's try this. Object type of coin is not JSON serializable. That's our little problem. We can't save coins directly, so here's another error. We have a type error, for example, here. So errors are really a part of this language. We can accept them almost everywhere where things can go wrong. So when we try to add, or when we added, when we save, we just dumped all the coins into a list. So we have to update this to well, a pretty formatted coin list. Make it coins to save. It will be a dictionary too, and for each coin, let's make it a did comprehension. So for each coin, in self dot coins, we iterate through all the coins, and we will have to add the key value pair. In each coin we have the name and the amount. So each coin's name will have the coin's amount. And this will be a simple dictionary created from our intricate and really complex coin class. And now we can add this coins to save dictionary directly to our JSON. And let's try this out. We have edited this, sorry. We have our wallet with empty coins, and after the second run, our wallet is updated. Something happened with the USD, I will figure it out soon, but we have 1 Bitcoin, 1 Ethereum, 5 Ethereums, a ton of Dogecoin, and we have also not existing coins. This JSON looks reasonable, but let's go on. So when we tried to make a coin, we had to add a name and an ID. So it will be a problem to create first, but we will tackle this problem later on. So let's update this. We don't want to add the name, but the ID. So let's update this. Let's run first with the empty wallet. Let's add the fake amount of stuff. And we will have 0 USD and the ton of data. The USD amount is 0 because when we load, we forgot to load the USD amount. Let's correct this first. Self.loaded wallet will be, just see next to each other, it will be a dictionary. It will have a USD key. So loaded wallet will have an USD key. This will be the value. So self dot fiat will be our USD amount. And since our wallet is now okay, we don't have to well, now we still have to fake some coins, so that's why we won't get updated values here. Let's run it once more, and let's add some value here, so we can see that it's loaded and overwritten by the stored correct amount. So we could store one value and load. We could store by ID and the number. But what we still need is the name based on the coin's ID. So when we start first, we list the coins. So from the all coins object, what we will have a really complex object, we can have these coins, and this supported coins only has the, well, we could improve this easily by storing the name here too. Let's just do that instead of requesting data from the API. We only get this for getting the list of supported coins, and I don't want to dig too much deeper here because it will just add too much complexity without a value. So we have to value our time first. We will save with each coin the amount and well, let's make it a dictionary too. It's not the best code, but we are in a hurry because we have other things to do. We have the coin.amount and name will be coin.name. And since we are here, we could just throw in a list of coins and call it a day. So this would be ID should be coin.id, amount, name. It will be easier because we are not depending on this yet. We can make changes easily. So let's delete our fake wallet and let's have a test run. First we have 0 USD in coins and 10k in USD. After we run again, we still have our 10k in our wallet because yes, we have our 10k in the wallet, and we have a ton of coins here. Let's just check out here. So we have it looks problematic, so let's format this document, and now it looks much better. We have our fiat, we have our coins, and yes, we can just have a list of coins. Each one has an ID, how much we have, or how many of them we have, and the name. Now we can load this properly. So with this try except, we don't do a really sophisticated error checking, because anything goes wrong, we abort the load and we fall back to this. We could do sophisticated checks if, when it fails, yes, try to load the other coins, but that's too much hassle. You probably malformed your file, or something went corrupted. Let's take better care of your data. Don't save here. So after we loaded our fiat money, we can access not just any data, we can access all the data. So we can iterate through each coin, because our JSON says, let's format again. If we access the coins, put it here. In self.loaded wallet, we will have a USD key and a coins key. Then we will iterate through one dictionary at a time. So each coin will have an ID, an amount, and name. So we can easily change this into, yes, create a coin based on the actual coin's name, the actual coin's ID, and actual coins amount. So now we have a somewhat safe way of loading and storing our current wallet. Let me just close this without saving. So now, if I try to steal all the time, after every load, or every time we save, or let's create a steal function just for fun. Well, let's take some USD from the amount. So if I already ahead of my thoughts, when should we take money from the amount of USD we have? If it's over 0. So if self.fiat is over 0, then we can take just 1 USD, because that would be the file opening and storing fee. Self.fiat minus equals 1. And before saving, always take some coins from the user, just for fun. After each run, we have some type error. String in this is not this integer, not string. We have another error. For each coin, yes, check out our wallet. Format, command format. Let's check out what happened. ID, name. It looks fine. What's the problem? String must be integers, not string. What happened here, probably. Let's just break for a second and let's load what's inside this self.allCoins. We probably caught an error live. Not to watch. Self is here, we are in the coin. Should be fine. In the coin we have we should have all coins here already. Let's check the response. Watch. Something went horribly wrong here, and even if we are debugging, doesn't give a clue for us. That's a big shame. That's a really big shame because we can't see what went wrong here, but what we can do here during debugging, just for these days, we will print this. I don't like printing, but yeah, at this time the debugger didn't want to tell us what happened here. So let's close it again, and it just ran perfectly again and again. And now we have a proper answer. We have exceeded the rate limit. I'm not saying it finally because it's not the best thing to see, but the thing is that if you ask such data too frequently, you can get a response like this. So we could do it's not an error here. This is a normal operation, and I would check if self all coins. First of all, we have to check if we have a status key in. Well, it can get pretty complicated, so let's do the complicated way first. So if status is in this self all coins, so if we have this status in here, because normally we will get in the JSON response all the but we have a response from before, and let's format this document. We have a shit ton of coins, but if we search for status, it's a status coin, but we don't have a status key in this. So if we wanted to check normally, let's do the wrong way. So if status has an error code 429, if status has an error code and it is equal to 429, then we print we are rate limited. Don't want this here. This means that we should load the data from a file like this coins.json. But otherwise, let's get the data we want. But this will also fail because we waited a little bit. The rate limit won't kick in. And if the rate limit is not kicking in, we won't have a status key which has an error code. It will throw another error. So let's run this again. And now the problem is that we have a proper response, but we don't have an error code. So in this case, after all this hassle, it's much easier just to try to read this, and if we have a problem, then we will have to load from a file and check later. So without doing too much work, I just add Bitcoin and the others used here in the example to a hard-coded list, or not list in this case, but a set. So if this fails, whatever the reason should be, the server is off, we are rate limited, we will go and have the fallback of it will be a set. Let's add Bitcoin, Ethereum, and Dogecoin, just for having something fast. So now, if I do this and reach the rate limit, we reached the rate limit. The print says, yes, we exceeded the rate limit. But we still worked perfectly because we handled the problem. It raised an exception, an error, and if we have enough scroll back, we can check what was it called. If I remember, it was type error. And it's too cluttered to see. But the main thing is that we did some error checking. We have a fallback mechanism. Of course, we will save the content and in a proper JSON file to load later on, but that's out of scope for today. Let's be thankful to have to load and save the wallet itself first. So now we have our wallet. We have ever losing USD amount and the supported and unsupported coins, what we can do our math with. This rate limit can kick in, of course, with the update too. So it would be nice to do this checking here too. So let's try updating this. Well, first, let's put this printing and checking into an infinite loop, and let's see how long does it take to get banned from CoinGecko. I hope it's not a hard ban, but if we run, for example, a few seconds, it should probably kick in. And it's not kicking in. I will stop abusing this API, so sorry guys. But it may kick in sometimes, so let's try to get this and converted. And except something, let's just handle the problem currently with can't update exchange rates. Okay, so we try to get a response. We will try to load this, and the exchange is we didn't make an exchange here, but the thing is, if the loading mechanism fails, we don't override the already okay exchange here, so it's okay to get the response and then try to do this in one step, because the exception will catch. We will print that yeah, we can't update the change, but you will be able to store the previous data. Of course, we could add if we don't have during load, we should load the last sane exchange rate just to have a fallback mechanism again. But for today, we want to add the save and load for our file, if I remember correctly. And what we want to do is some error checking. So that should do the trick for today. What we could have here also is arranging this to an else block. Why? We tried, well, of course, this can also fail, because we may not have USD or CoinSki here. So it's not the best idea to add or remove them from the try block. But yeah, let's see for other cases when we can add the proper as block. So first we try to load them if this fails, but not just this, sorry. With loading, we can fail for getting the response, and we can fail by getting the wrong answer. So now we can finally differentiate, and this will be a good example. We can accept what kind of error? We can accept a connection error. This error comes when we try to get the API response, but it fails. The internet is off, the server is down, whatever happens. If the connection is down, then we should load the file. But if we have a key error, and if I remember correctly, this would be a key error Or was it type error? It was type error maybe, sorry. So if it's a type error, let's correct it somehow. So if we have a connection error, we should load from a file. If we have a type error, we should also load from a file and add all these. But here comes the possibility to handle them correctly or differently. If we have a type error, or let's just handle everything else here. If something comes up, we are probably rate limited. And load whatever we want. But if we have a connection error, can connect to the server. Maybe the server is down, maybe something else happened. But now, if we remove this monstrosity here, we can try to get another error, another rate limit. So let's run once, let's run twice, and we failed somehow, but it didn't throw a connection error, it threw a different type of error. So we handled it by saying, yes, we are probably rate limited, and we stayed here. So different except blocks with different filters for different error types can differentiate between errors, and we can handle our errors according to what actually happened. So today we added some loading, not too much. We loaded a hard-coded wallet JSON, and let's already refactor this to a proper variable so we can edit it later on easily. So today we added a save next to the load, and now we don't have a mocked save file, we have a proper save file. Well, it can be improved, but it currently holds our coins correctly and the amount of fiat we have left. If the load fails, we handle it with the try except method, where the file is not existent yet. Then we will start the game with the basic amount of money and 0 coins, because we didn't have any coins left. And anytime we make a transaction, we will try to save the state. We open the save file, and we will store, well, wasn't the best method or the prettiest method, but we quickly save our data into a JSON file. And of course this can also fail, and that will be the worst part. So let's try this, and we can't really do anything here. We can warn the user that can save the wallet data. That's a huge problem. So we hide this error now, but at least we try to warn the user. Why can't we open the text file to write? Maybe if the file is not existing, then we create the file. That's not the problem. If the file is already opened by someone, then maybe we can create a fallback file or something else. But the main thing is that we added try except block, hopefully, to every possible problematic part. update here too. Yeah, this can also fail because could fail, but I think we already handled that with the checking if it's even here, so that's not a problem. And yeah, remove the fiat stealing technique here because that just doesn't make sense. So for today we were introduced to the error handling. We will sophisticate it later when the possibility comes, and we added some file handling because we will need to save the state of our application. And then at the next episode we will probably do this check periodically, update the data, and soon we can move on and have a graphic interface for our data. So thanks for watching, and let's meet next time.